Welcome back to Cloud 42, I'm James. Today I think we're going to finish up the last mechanical part of the Toolpost Grinder, and that is the wheel guard. This is part 22 of the series, and as always there's a link to the rest of the series playlist down in the description. Before we get started today, I want to talk a moment about safety. Now, grinding wheels spin fast and they develop a lot of kinetic energy in the wheel when they spin. And you don't normally notice this because the grinding wheel normally stays in one piece. But wheels can and do fail, and when they do, they can throw pieces of the wheel at very high velocities and cause very serious injuries or even death. About 20 years ago, I took a shop safety course that was offered through my employer. It was a prerequisite for employees who wanted to use the machine shop that they had available on site. And in this class, the instructor told a story about somebody that he had previously worked with. He said this guy woke up one morning having had a dream about somebody being injured in an accident at the shop. So he decided to stay home. It rattled him so much he called in sick. And later in the day, he went down into his basement where he had a little hobby machine shop and to work on a little project. And when he spun up the grinder, one of the wheels exploded and killed him. Now, you can take that story any way you want, but my point is this. The guard on a grinding wheel is a safety device, and it is there to keep pieces of a failing wheel out of your teeth or worse. So I am going to show you how I made the guard for my Toolpost grinder, and I'll make drawings and files available if you'd like to make one yourself. But please understand that if you decide to make one yourself, you're doing so at your own risk. You need to understand the forces and energies involved, the materials you choose to use, and the fabrication methods that you choose to use. Make smart decisions and be safe. That said, let's go over to the bench and take a look at the plans. I spent a lot of time trying to figure out exactly how I wanted to put together a guard for the Toolpost grinder, and this is what I came up with. You can see here in the isometric drawing, it's two parts. It's a hollow back piece that has a back plate and a wall that goes around the wheel, and then a front plate that screws on with 5 832 screws. Now, I spent some time trying to figure out, exactly how to go about fabricating this. This is kind of the design that I had in mind, but this is tough to make. I could make, a couple of plates on the milling machine and, web them out nicely like this if I wanted to, or just leave them as flat plates, and then make a ring that screws in from both sides, or maybe is welded in. You could do this with a piece of tubing or a heavy ring roller, but it's a lot of work and it's kind of hard to hang on to. There's a lot of really awkward setups. If you want to, and I don't have a welder, so if I wanted to mill this out of a solid piece of aluminum, we're talking about maybe a 6-inch round, 5.5-inch round, 1.5 inches thick, and almost all of that ends up being converted to chips. So that's going to take a long time, it's going to be expensive, and it's not going to be very efficient. Somebody in one of my videos suggested 3D printing the guard. Now that's something that I just dismissed up front because I was concerned about the strength. And the primary issue is the layer adhesion. Certainly PLA would be right out. That material is way too brittle. ABS or maybe PETG might be okay. They do have the tensile strength if they were injection molded to make something plausible, but the real issue is the layer bonding. So the layer adhesion between the layers, this would be printed flat, and so it would be built up in this direction, layer by layer, and the adhesion between those layers is always a weak point. So I was just too afraid that if I did have an accident and had a wheel burst, it would delaminate and the guard would fail and wouldn't do its job. But then I realized all 3D printers don't work that way. So I had these parts printed on an HP Jet Fusion 3D printer. Now the way the Jet Fusion, I don't own one, I know a guy. The way the Jet Fusion printer works is it builds up layers of powder and it melts those together, somewhat like selective laser sintering, which melts with a laser. But the way this process works is I think they spray down using an inkjet head, comes across the powder and lays down an infrared absorbing material, and then they flash the whole thing with an infrared lamp, which melts where the plastic powder together where the infrared absorbing material was placed. So this is nylon, PA12, with a tensile strength around 7,000 PSI. And the great thing about this is that even though this is built up in layers, the strength in the Z direction is almost exactly the same as the strength in the X and Y direction. So you get that 7,000 PSI in every direction. So just for comparison, a mild steel, like a cheap rolled sheet metal, like you would find in an import grinder guard, is probably going to be around 25 to 30,000 PSI, which is, quite a bit higher than this, but the material is also very thin, about 1 millimeter thick. And so what I chose to do here is I'm using, again, a 7,000 PSI material, but I made the wall much, much thicker. This is over 6 millimeters thick. It's about 1/4 of an inch. And that gives the added strength. This is solid all the way through. And again, you get that 7,000 PSI in every direction. So I'm satisfied with this. Certainly if you make a guard for your own grinder, you're going to have to decide what materials you want to use and what you're okay with. But I'm going to proceed with this. I'm happy with this for my personal use. Now, in order to put this together, we've got 5 832 screws. And I don't know if you can see this, but I actually modeled the 832 screw threads right into the holes. And the printer did a really good job. Let me see if I can get you a shot here. The printer did a really good job of printing those. You can see the threads in the holes. Now, I have done nothing to this. I haven't run a tap through them. Those are just exactly as they came off the printer. They get de-dusted and sandblasted to remove the excess material. And I'm actually pretty impressed. I'm going to try running some 832 screws into there and just see how they work. Worst case scenario, I can run a tap through to clean them up. But I'm going to give it a shot without first, just to see how it goes. Oh, that goes really easily. And it bottoms nicely. Okay, I think that is going to work. I don't even have to clean those up. Okay, so to connect this to the grinder, there are 2 holes here for 1/4 28 screws, and we'll make a couple of spacers so that that will space off of the tool post clamp. Spacers are just going to be made from a piece of 1/2-inch drill rod. I'm going to make 2 of them, put a couple of flats on it so it's easy to turn, and we'll just drill and thread it all the way through. So I can use, this is enough for 2, so I can use a piece of 1/4 28 screw to mount this in, and then a 1/4 28 screw to mount the guard onto the other end. And then we'll of course also have to take the tool post clamp here and drill and tap a couple of holes in it to actually accept those. So I think we've got everything that we need. I already faced the ends of this to get it square. Let's start by going over to the mill and putting some flats on this. Okay, I've got the piece of stock here that we're going to use to make the 2 spacers, and I just need to put some flats in it. And to do that, I'm going to hold it in a collet in this collet block. And this is going to go in here like this. We just snug that down. Grab a 1/2-inch ER40 collet. Make sure this is clean. And put this in. I think that's probably going to be about good. Let me grab a wrench. Now, I'm going to be flipping this around. I'm going to be doing the top and bottom, and then I'm going to be flipping it and doing the other end as well. So I want to stop. And since I'm going to take this out and put it back in, I can't have the stop on the block. I got to have the stop on the end here. So So let me grab a table stop here. Okay, that should be good enough. Okay, so if I loosen this, I should be able to bring this out and touch that. That'll give me a point where I can reposition it over and over and over again. Now ultimately, the only thing that matters on this, since I'm going to be going back and forth this way, is I just have to find this end. So I've got an edge finder in here, and let's find that edge. Okay, got my 0 set on the end there, and according to the drawing, I need to go in 585 thousandths. So let's just go in. And that is close enough. So let me get this tool out of here. Let me grab a 3/8 inch end mill. I think I'm going to run this directly in the R8 collet. So Tormach collet out. Okay, I'm just going to bring this down a touch and figure out where we are. Okay, so that's about 0. I'm going to take it down. Let's see, this is a 1/2 inch. I'm going down to 375. So I'm, a few thousandths in there. But it's 1/2 inch minus 0.375, which means I need to go down about 125 thousandths and take about 1/8 of an inch off of this. Total, divide that by 2 means 62 thousandths. So I'm going to take it down about 30 thousandths first, and then we will get a measurement. So I'm just going to 0 my Z right here, and I'm going to dial the Z down around 30 thou. Okay, that's close enough. Okay, get a little bit of coolant on here, take a cut. I do need to slow this way, the feed way down. Let's take this down to 2 inches a minute, just because we can. Put the mill back in high gear. And we'll make a cut across. Okay, now I'm just going to flip this over. And we're going to make the same cut on the other side. Close quarters in here. Okay, now we just have to measure and see what we actually got. I'm going to go ahead and pull this out because that makes it easier. Like actual is 437, 438. So I'm at 438 minus 375 divided by 2 means I need to take another 31.5 thousandths. I'm going to take 32. I want this slightly undersized so it'll fit the wrench easily, so I think I'm going to take 33 more, which will bring me down to 63. Okay. I have a 3/8 inch wrench here. Oh yeah, and that fits just fine. That is going to work great. So now I just need to flip it around and do the other end. Okay, and looks like my 3/8 inch wrench fits on that side as well. So that's all I need to do. I just need to get this out of here, clean up the burrs with a file, and then we'll cut this in half. Okay, next thing we need to do is drill and tap 2 ⅛/28 holes here and 2 on the other side. And since I'm going to be flipping this over, I want to make the setup simple, so I've got my stop clamped onto the back vise jaw there. That way I can just put the part in like this and clamp it down, and then when I'm ready to do the other side, I can just flip it over. I don't have to indicate anything in again. Okay, first thing I need to do is get a 0 on this side and find the center so that I can offset for the 2 parts, and I'll use an edge finder for that. Okay, let me put in a spotting drill and let's spot some holes. Okay, now I'll spot these very, very gently so we don't push the drill too far off center. Okay, now I've got a pilot drill in here. I'm just going to zero this out on a 10 thou shim, zero my DRO. Now I need to go into a depth of 565, so because of the 10 thou shim, I'm going to go to a depth of 575. And I'm just going to read that right off my DRO here. It's 100, 200, 300, 400, 550, 560, 575. Okay, now this is a number 3 drill, which is tap size for a ⅛/28. Here's my ⅛/28 tap. And we'll just tap these holes. I'm doing this by hand with a tap follower. because this is a spiral flute tap and it's pulling things up out of the hole, I don't need to worry about packing chips into the bottom. And speaking of the bottom, there it is. It's kind of hard to do reaching around the camera like this. I love the spiral flute taps. Okay. Okay, let me deburr the top of the threads just a bit. And there we go. Good to go. Okay, we've got a flat in each end of this piece, so we just need to cut this in half because this is going to be two different spacers. I'm going to go ahead and sink it in here. Let's look at the drawing. It's like the overall length of the thing is 1170. Which is inside the vice jaws and is about right there. So I've got plenty of room here to cut this. And I'm, again, just going to do this with a hacksaw. I could try to do this on the bandsaw, but holding onto a piece this small is really tough. So the hacksaw will get the job done. This is tool steel, so it's a little bit tough, and so it's cutting slowly and bouncing out of the groove. There we go. Now I just need to take these two pieces over to the lathe and face them to length and put some threads in them. Okay, we have both of these cut off now, and one end is already faced and clean. We've got the flats in there. Now we just need to face them to length. Now to do that, I'm going to stick them quite a ways out of the chuck. And the reason I'm going to do this is so that I can get calipers behind it to measure the length. Make sure it's tight, because it is sticking out quite a bit for its diameter. That looks pretty good. Let's face it off. Okay, so the length of this needs to be 1170. So I'm going to bring this out to 1170. Uh, 1170, zero it. Now I can measure this. Turn this over so you can see it. And it looks like we need to take 144 thousandths off. I've got my dial indicator. There's 0. 15. 1. There, we're within 1 thou, which is good enough. Let me just take the burr off the edge. There we go. We'll come back and drill this later. Let me face the other one to length. Okay, Next thing we do is just poke a hole through this and thread it. Then we grab a drill chuck. Okay, first thing I'm going to do is just spot the end. I'm just going to use a center drill for that. Now I'm going to use a small drill and just pilot this through. First, I'm going to slow this down quite a bit. Letting the tip find its own center here before I start pushing. Now I'm not going to try to go all the way through this. I'm going to go about halfway from each side. And there's about 3/4. 3/4 is far enough. Now the number 3, which is the tap drill. Tool steel is actually getting pretty hot. I'm just going to slow it down even further. Now I'm going to flip the part around and do the same thing from the other end. In fact, I'll go ahead and do both parts from both ends. Okay, I got a 1/4 tap here, and we're just going to go ahead and push it through. Now I'm going to set this up and run it under power, I think. Am I? You know what, I'm not. I'm just going to hand tap this. This is pretty tough stuff. Great, now let's flip it around, do the other side. You don't have to watch this, it's going to look exactly the same. Well, it's a man in a white van trying to sell ice cream to kids by playing music. This, you know, That seemed okay when I was a kid, but boy, today, that seems kind of questionable. Okay, that's the last of the tapped holes. I think we're about ready to put it together. Okay, let's put this whole thing together. So I've got the tool post block in here. I don't have the grinder in it, just so it'd be easier to see what's going on. So I've got these spacers with the flats. We put a piece of 1/4 28 screw in there. Actually, you know what? I'm going to put them in here first. Let those kind of bottom in the hole. Then we'll put on a spacer. Snug that down with a 3/8 wrench. Put on the other spacer. Snug that down with a wrench. Oh, those are really solid. Very happy with that. Okay, and then this is the body, and it goes on with 1/4 28 button head screws. Hey, the hole's lined up. That's awesome. Let's see, what size are these? Oh, nope. Okay, that's the body of the grinding wheel guard. Oh, that's nice and solid. Oh, by the way, there's a drain hole down here in the bottom. I don't know if that was evident earlier. That's so that if I'm ever grinding with coolant, it won't pool up in here. It can just dribble out. Okay, let's put in the grinder itself. I think we've got the depth right, but we can adjust the wheel later if we have to. Speaking of the wheel, here it is. And I'm going to put the drawbar in from the other side. I think this drawbar is a little longer than it needs to be. I may trim that off at some point. Okay. It's nice. I got about a 1/4 inch gap between the 4-inch wheel and the inside. What are we doing for center? Feels pretty good. Okay, now let's put the screws in the cover. For 4 of these screws, this is the first time they've ever gone in, and I'm pretty happy with it. It feels pretty good. Those printed threads modeled into the part worked out great. Okay. That looks nice. Nice and rigid. I'm very happy with that. That's more rigid than the guards on my bench grinder. Well, that is the wheel guard for the Toolpost Grinder complete. I could not be happier with how that turned out. It's nice and rigid, and I'm very pleased. We are just about ready to run this thing in anger for the first time. The only thing we still need is a single point diamond dresser so that we can dress this wheel square and concentric before we start grinding, and we will work on that next time. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.